So, start of Unit 5, Solutions to Linear Systems and Solving by Graphing. So, systems of equations. You did a lot of this in 8th grade. You might not remember it. But hopefully today is pretty familiar since we're doing the first lesson. It's just like a review of 8th grade. How do we know something is a solution to an equation? Which is what's in here in this box. To do this, we need to make sure that the point is true in the equation. And that's a collection of pairs x, y to the system. So we're going to start off pretty basic with two systems, A and B, and a point 2, 5. And it wants us to determine if it is a solution. We did the same things with single equations, where we just plug in and make sure it's true and false. Since this is a system, you must assume that both must be true to be true, so an and statement. So you must plug into both. So what would that look like? Well, if we start with the first equation, I'm plugging in 2, 5. I'm simplifying it, and it works. Start with this now the second equation. Plug it in. So 2 times 2 plus 5. 2 times 2 is 4. It works. So this one is a solution. So this one is true, because it worked for both. Okay, you try exercise B. You can pause the video, try it, come back, check your work, see if we have the same work. Okay, let's plug it into the first equation. So 5 minus 2, which is 3, so it works. Try the second equation. So 5 equals 1/2 of 2 plus 6. 1/2 of 2 is 1, and 1 plus 6 is 7. Does not work, so this one is false. So if they give you a point and they want you to find out if it's a solution, you must try it in both. If you get two truths, it's true. Now, that's one way to determine if a point works. Now, to solve a system of equations. So now they haven't given us a point, but they've given us two equations. You are able to graph both lines, both equations, find out where they intersect. See, at what point do the two lines intersect? That is the solution. Now, graphing. Again, two options. We talked about this in Unit 4. A, using your graphing calculator and using the table. You see this in part A. Or B, if you know how to graph without using your calculator, go ahead, graph them on the table, on the grid, and find where they intersect. So pause the video again. Go ahead and get both of these lines graphed. Okay, so I'm just going to graph using 1, 2, 3, 4, the slope-intercept method. Oh, down 2 over 1. Get rid of that point. So here's the first one, 2x plus 5. I'm going to label it. Second one, let's see. We start it here. And we go like this. It's a negative slope. -1 technically, over 1. So there's that one. I can clearly see where these intersect. Circle it. Everybody circle the intersection. So now, part B says, where do these intersect? Let's write the point on the graph. What is this point? Well, it's left 1, which means -1. -1, and up 1, 2, 3. And there it is. We have now found the solution to that system of equations. So you can find the solution by graphing and finding an intersection. Now, when does this work? When your intersection is right on a point. If my intersection falls on a random spot, I cannot use this method. So now it wants us to show that it works. Well, you must rewrite both equations. So 2x plus 5 and 2 minus x. You must plug in that point and make sure that they both are true. Go ahead, pause the video, plug these 2 points in, and see if they are true. Okay, plugging them in. 2 times -1 is -2, and -2 plus 5 is 3. And this one. Double negative there, so you add them together, and 3 equals 3, so it is true. So that's graphing lines and finding the intersection. So it's easy to see why the method of graphing works if you understand the truth about graphs. Remember, graphs is equation. A point lies on a graphing equation makes it true. The graphing equation is simply the set of all points that make it true. So now we got a little bit of fill in the blank here for vocabulary words in this unit. You have 4 words here: true, intersections, solutions, both. And I need you to place the words where they belong. So it says, to solve a system of equations graphically, you find the blank of the 2 graphs. Think about what this would be. I hope you thought intersection. That's where they come together, the meeting point. This works because any intersection point must lie on blank graphs. Think about it. Where does this intersection point lie? So we've used this word. So hopefully you thought both graphs. Because intersection points lie on both graphs, they must make both equations. We got 2 words left: true or solutions. It is definitely true. And then because intersection points make both equations true, they are solutions to the system of equations. It's a little bit of words here. So we often use graphing to solve systems in applied problems. So here we're going to do a real world example. So here is how this is going to work. You got Janelle and, this is the weirdest name, I think you say Swetha, I don't know. But they're taking a 50 question true-false test in their history class. Janelle started after Swetha had already finished 12 questions. Janelle answers questions at a rate of 2 per minute, while Swetha answers them at a rate of 5 every 4 minutes. Janelle eventually catches up. How many minutes does it take her, and what question are they on when Janelle catches up? So this is what we're trying to find. Where are we going to find that? We're going to find that in the intersection. So we need to get 2 lines graphed, one for Janelle. So we've got Janelle, I'm going to say J, and we got Swetha. We need to create 2 lines that we can graph. Now think about Janelle. She graphs questions at a rate of 2 per a minute. We know the word per. What does that do to the equation? Where does that 2 go? Think about it. Write down an equation for Janelle. So 2 per minute should look like something like this. That's Janelle. Now Swetha is a little different. She starts after 12 questions have already been answered. And she works at 5 questions every 4 minutes. 5 questions every 4 minutes, that's your rate. Your rate is your slope. Your slope is your m. Your m goes in front of x. So what is their slope? 5 over 4. And we're going to put an m there because that's the x in this case. That's the variable we're using. But she starts when 12 questions have already been answered. So you got to put that 12 there. So now that you have the 2 equations, you can A, graph them in your calculator. Just remember to put an x here. 2x, 5/4 x. Graph them in your calculator, get them graphed. Or B, you can use the slope-intercept method where you put your point and then count up and over. Go ahead, pause the video, get these 2 lines graphed. Okay, I'm going to start with Janelle. She doesn't have any y-intercept, so technically it's 0. And every minute she goes up 2 questions. Careful here. This is going up by 2. 2, 4, 6, 8, 10. So technically, I'm not going up 2 boxes. I'm only going up 1. So this is Janelle, all the way like this. So I'm going to extend her line carefully. And here is Janelle. Now Swetha's different. She starts with 12 questions already done. So I got to go up to here. This is 12, right? Because it goes up by 2, so 10, 12. And then I got to go up 5 over 4. Weird, though, because to go up 5, you don't go up 5 boxes. You technically go up 2, 4, here's 5. 1, 2, 3, 4. So it falls in the middle, which I find weird. But 2, 5, 1, 2, 3, 4. 2, 5, 1, 2, 3, 4. 2, 5, 1, 2, 3, 4. And here's our intersection. And here's Swetha. So now, if we want to write that point and figure out the answer to the number of minutes and how many questions that answer here, let's go up and count. Let's see, where are we at? 15, 17? Yep, 17 it looks like. Or maybe it's 16. Oh, I got it wrong, I think. 15. Here's 16. Yep, there's the intersection. Maybe if I had my line drawn completely right. There we go. 16. So 16, and how many up are we? 32? So it's 16 minutes. That's how long it took her to catch up in 32 questions. And that's the lesson for today. Just simple graphing 2 lines, finding their intersection, which is the solution, plugging in the solution to make sure it's true. What I would like you to do is now go ahead and do the practice. I don't think I want you to do all of these just because it'll take you some time. So maybe do 2 and 3. Go ahead and do those 2, graph them, find the intersection point. So I want the point of intersection, where they intersect on those graphs. When you're done with that, make sure you do the exit ticket. When you are done with the exit ticket, you have time to definitely get a head start on this homework, which we will be completing on Monday.